Bismillahirrahmanirrahim. Today we discuss about electrolysis of molten electrolyte. Molten electrolyte or fused electrolyte means the ionic compound in pure state without adding water. Now we discuss about the basic theme first one, that is when molten electrolytes, like we take any molten electrolyte, these molten electrolyte move towards anode and cathode. So now we discuss about the reactions at anode and the product form. At anode what happens, and at cathode what is your product. So this is very important. During the process all the negative ions moves to anode, and negative ions are always with the non-metals. Non-metals contain negative ion, they are moves to anode, they are losing electron and form non-metal as a final product. तो ये बच्चे आपका नॉन मेटल बनेगा always at anode, because non-metal ions are always negative ions. The negative ion attracted towards positive anode. Anode is positive terminal, cathode is negative terminal. So metals are the final product at cathode and non-metals are the final product at anode. Now we discuss about some examples. Electrolysis of molten electrolyte. First one we take the common salt NaCl in fused or molten state. NaCl is electrolyte in molten or fused state that decompose into its ions. These are positive ions and negative ions. These are positive ions and negative ions. The positive ions are named as metal ions. These are the metal ions. And negative ions always are the non-metal ions. We take different examples here to clear the concepts. Now, during the electric current or electrolysis, there are two reactions at anode and at cathode. We know that anode is the positive terminal and the nature of reaction is loss of electrons, mean oxidation. तो इलेक्ट्रॉन हमेशा लॉस होंगे एनोड पे, and cathodes are the negative terminal and always gain of electron take place at cathode. Out of these two ions, the negative ions attracted towards positive. All of the negative ion moves to anode, that is Cl negative, and we know that at anode loss of electron take place. So when it losing electron, Cl negative lose electron, it has one charge, it losing one electron to form Cl, which is non-metal, but non-metal exists in diatomic state. In order to balance the equations, we should write two here. We should write two electrons are lost. So look at that. This is your non-metal chlorine formed at anode. So anode always produce non-metals. And at cathode, the positive ion moves to cathode where they gain electron. Where they gain electron to form neutral atom or sodium metal. So this is the reaction at cathode and always metals are formed at cathode. Look at that. At cathode metal is formed. तो ये बच्चे आपकी short trick इसको learn करने की for all kinds of reaction. And now if your demand like you write overall reaction or redox reaction, because anode reaction loss of electron is named as oxidation reaction. And the gain of electron is called reduction reactions. तो अगर आप इन्हें ऐड कर लो, रिएक्टेंट्स को रिएक्टेंट्स में ऐड कर लें, प्रोडक्ट्स को प्रोडक्ट में ऐड कर लें, दे आर कॉल्ड redox reactions. In order to write redox reactions, also named as overall reaction, but for overall reaction we have to balance electrons on right side and on left side. There are one electron, there are two electrons. So before redox reaction we have to balance, like 2Na multiply with 2, because we are going to balance electrons. तो आप इन्हें ऐड कर लो, reactant में 2 Cl negative, reactant में 2 sodium ion as well. और बच्चे आपके 2 इलेक्ट्रॉन से कैंसिल. On the right side your answer is Cl2 chlorine and your answer for next one is sodium. So this is your complete redox final equation. Now we take some other example as well. Now we discuss about electrolysis of molten lead bromide PbBr2. So first one, we should decompose the ionic compound into its ions. That is, first part of electrolyte is always positive and second part of electrolyte is always negative. And the number which is written to the second part, that is 2, that goes to lead. And lead, there is one lead to bromine having one charge, means -1. And now there are two bromine, so you have to balance the equations. Reaction at anode and reaction at cathode. Positive part is anode, negative part is cathode. Loss of electron take place at anode. This is called oxidation reaction. And gain of electron take place at cathode and named as reduction reaction. So anode is positive, it should attract the negative ion, that is bromide ion. So all the bromide ion moves to anode where they are going to lose electron. Lose means electron आपके right side पे आएंगे. So one charge is there, one electron is lost. But bromine exists in the form of bromine because non-metal exists normally in diatomic state. Should write 2 here. So in order to balance bromine, we should write 2 here. So one bromine losing 1 electron, 2 losing 2. So your product at anode is non-metal. Look at that, non-metal at anode always. That is bromine. At cathode, that is the positive ions, lead ions moves to cathode because they are attracting towards negative cathode and gain electron. जितना charge है उतने electron gain होंगे and your answer is lead. This is balance equation. Now write redox or overall reaction. आप इन्हें बच्चे ऐड करो. Reactants 1, reaction 1 में बच्चे 2 bromide ions, then 2 lead 2, that gives you electrons cancel. Now your answer is Br2 along with Pb. To Cambridge demand the questions in the molten lead bromide, which ions are present? So you are asked the ions are, the answer for this question is the ions are lead 2 and bromide ions. P are negative. These are the ions present during electrolysis. And the question is the product at anode and cathode. So your answer is, for this question, anode product is bromine. Bromine is the product formed at anode and lead formed at cathode. This is the question. Cambridge demand the questions that which are the ions present, what are the ions present, what are the products during electrolysis at anode and cathode. So this is a simple way to understand electrolysis of molten electrolyte. Now we take one more example that is very important. Electrolysis of molten alumina Al2O3, also named as bauxite ore or alumina as well. Now we take first one. This aluminum oxide decompose in molten state into its ions, that is aluminum ions and oxide ions. We know that first part of electrolyte is positive and second part of electrolyte is negative. And the numbers, that is 3, that moves to aluminum, means aluminum 3 plus ions, and this 2 number with aluminum moves to oxygen. We should write the ions by cross multiplying the numbers of oxygen and aluminum. Now there are 2 aluminum, so you have to balance aluminum, and there are 3 oxygen, you have to balance oxygen. Now the reaction at anode, first one. Anode is the positive terminal. All the negative ion moves to anode where they are going to lose electron. Which electron lose karoge, you got oxygen by the loss of 2 electron. But O is non-metal that exists in diatomic state. So you have to balance 1 oxygen losing 2 electron. We have to balance, there are 2 oxygen, there should be 4 electrons. And now at cathode, the negative part of battery, that all the positive ions moves to cathode they gain electron. Having 3 charge should gain 3 electron to form aluminum. This is the reaction during molten bauxite ore. The products are oxygen at anode, aluminum at cathode. But we have to write the redox reaction as well. But for writing redox reactions, we have to balance the equations. In order to balance electrons, there are 4 electrons in reaction number 1 and 3 electrons in reaction 2. To multiply means cross multiply. To balance the electrons, multiply with 3 and multiply with 4. And then add the equations. Multiply with 3, here you got 6 oxide ions, that gives you 3 oxygen and 12 electrons. Multiply 4, here you got 4 Al positive 3 ions, 12 electrons and 4 aluminums. Now you going to add the equations. Acha ne add kar lo. So you got 6 oxide ions on the left side and 4 aluminum ions on the left side again. 12 electrons are cancelled. On the right side you got 3 oxygen and 4 aluminum. Can we demand the question here? Ions, what ions are present? So ions present, this is your aluminum ions here and oxide ions, O negative. And node product is, you got final product at anode, that is your oxygen. And cathode product is, that is aluminum. So these are the question demand from the Cambridge paper. Now we discuss the question that is in the Cambridge exams. The question for the Cambridge paper, you are given some table, you have to complete the table. That is, the first column you got molten electrolyte. In second column we are given the ions present. Third column you are asked the product at cathode and product at anode. We are given the different electrolytes and we have to complete the table. First one we take like sodium bromide, molten sodium bromide, then aluminum oxide Al2O3, then magnesium chloride MgCl2. We write lead bromide PbBr2. So we have different electrolytes. We have to identify the ions present, product at anode, product at cathode. This is very simple because we have only 2 ions. So ions present are sodium ions and bromide ions. Here you got aluminum ion, the 3 for oxygen goes to aluminum. We should write Al plus 3 ions and O minus 2 ions because 2 for aluminum goes to oxygen, cross multiplying with valency. Here you got Mg plus 2 ions and Cl minus 1 ions. Here we got lead 2 ions and bromide ion with negative charge. So they are the ions present during electrolysis of molten electrolytes. And now we discuss about the product at anode and product at cathode. So cathode having negative charge, anode having positive charge, that thing should be in your mind. So all the positive ion goes to cathode and forms sodium. This positive ion goes to cathode, form aluminum is the product at cathode. Here you got magnesium metal, here you got lead metal. So look at this one. At cathode always metal is formed as a final product. So these are the metals from the ions. And cathode, your product is non-metal. So all the negative ion moves to anode and forms the product that is non-metal bromine. Oxide ion form oxygen. Chloride ion forms chlorine as a final product. Bromide ion forms bromine as the final product. So this is the question that can be demand for your Cambridge paper.